Hey guys, what's up? It's Leaf from Excess Software, and today I have a pretty special video. It's going to be a technical video building decentralized applications on top of Cardano. The idea for this application comes from a viewer, actually, an on-chain application that verifies a set amount of a fungible token is always equal to any one NFT in an NFT collection. So you can freely swap X number of tokens for one of the NFTs in the collection, therefore enforcing that every NFT in the NFT collection is valued the same. This application will display a lot of the really good core concepts for building on top of Cardano. For example, it's going to go into how to mint native assets on Cardano, how to play around with native assets, and how to use spend validators to check transactions and interact with smart contracts. So all that is going to be covered in this video. We're going to be using the Lucid Cardano JavaScript off-chain transaction building library, and this is the library we'll use to build our transactions. It's all going to be in JavaScript with a Dino runtime, and we're going to use the Aiken smart contract programming language in order to write our Cardano spend validators and compile that into a smart contract. We're also going to cover deploying the smart contract. I really hope this provides a lot of value for the people out there, but I think educating more developers will be a net positive for everyone in the Cardano ecosystem, so I think it's worth the investment. If you're interested in these types of videos, please let me know. If I get overwhelming support on these technical videos, I will continue to do them. If I do not get overwhelming support, I will not put in the effort to build, to display technical videos on YouTube. It just simply won't be worth my time, right? So what qualifies me to make a video like this, a technical video about development on Cardano? Well, I actually do work full-time as a developer in the Cardano ecosystem. I run a small software development services company called Excess Software, and we partner with startups and medium-sized organizations to build applications around the Cardano ecosystem. So I have some experience in developing in the Cardano ecosystem, and I'm comfortable with all the concepts discussed in this video. If you're in the market for development services, you can hit me up. My email is leaf@excess.software. So you can find that in the channel description. I am booked through April practically right now, so I'm not looking to take on new development clients in the next 2 months, but I'm always open for a free technical conversation, free technical consultation. All those disclaimers out of the way, let's get into actually building. All right, so let's get set up. First of all, you're going to need some sort of way to visualize what's happening on chain. I'm using a web wallet, and I loaded up my seed phrase that I generated. Then we're going to need a pre-prod testnet faucet to give ourselves some testnet ADA on the pre-prod network. So make sure everything you do is set to pre-prod. This page right here is where I receive my pre-prod testnet funds. You're going to need to generate a wallet if you haven't done so already. So I have a script in the GitHub repository linked below that is going to generate a seed phrase. Again, don't use the seed phrase I just sent there, especially to hold real funds, obviously. Now we're also going to need some way to view the chain. The easiest way to do this is to sign up with BlockFrost and make sure you're on the pre-prod network, and also make sure to copy that API key and then paste it in the environment file, the .env file, in your project when you're working with the project you copied from the GitHub repository. All right, let's spend some time thinking about the architecture of the application. So, of course, we have a smart contract address, and this lives on the ledger, right? So this is an address similar in function to the address that you would control with your wallet. So you have a private key, and you have control of all the UTXOs associated with that wallet. And then, so you can generate multiple addresses and then multiple UTXOs underneath a single wallet, right? So this address contains many, many, many UTXOs, and these little diamonds represent UTXOs. Now, each one of these UTXOs carries the actual value of the smart contract. This is something we all know, of course. So if this UTXO carried a balance of 10 ADA, and this UTXO carried a balance of 10 ADA and maybe a few tokens, right? Maybe a few native assets on Cardano, 10 fungible tokens, 1 NFT, then the total value of the address of our smart contract would be, of course, as you can easily calculate, 20 ADA, 10 fungible tokens, and 1 NFT. Nice. So each one of these UTXOs lives completely separately from the other UTXOs. And this is really just the beauty of a UTXO-based accounting model. UTXOs are the superior way to run a blockchain. That's my opinion, but I think it's pretty proven at this point. A validator. What is a validator? Well, we're going to talk about spend validators today. Spend validators are something specific to smart contracts. And this spend validator is a guard. It's a check that makes sure if a user tries to spend the UTXO of a smart contract address, you run a script and you say, based on all the checks we had, they can or cannot spend this UTXO. So smart contract addresses are objectively different than your UTXOs on your wallet because you have full control of all the UTXOs that are underneath your wallet, right? The right to spend those UTXOs is yours because you own the private key. Smart contract addresses do not have a private key. So the right to spend them is completely defined by the spending validator. Again, just a guard, a single guard. We are going to write a validator, a spend validator, that makes sure in order to consume the fungible tokens or the NFT at a certain smart contract address, you need to send the equivalent number of fungible tokens or an NFT back into the contract. So you have to swap it. Our validator is going to say, if you want to consume a UTXO with one NFT, you must also send 10 fungible tokens back to the smart contract address. So that is all we're going to be validating with our spend validator. All right, great. Let's actually hop into the code. So first we need to deploy a fungible token. So these are the fungible tokens we're going to use for the swap. And we're just going to assign some arbitrary value. It's going to be 10 fungible tokens equal one of our NFTs. Now, this NFT collection needs to contain the same policy ID, and the fungible tokens also need to have a separate policy ID. So as you can see, I'm running Dino, the JavaScript runtime Dino. And what I first do is I set up a new Lucid client. This comes from the Spacebuds Lucid JSR package. You can get that, or you can just clone the repo. Then I need to, in my env, get my seed phrase, which is the wallet we generated earlier. Then I need to define a minting policy. Then I define the name of the asset using the policy ID I derived from the policy, the minting policy, and then also assigning the name. Then turn that into a hex string. Then just mint it, right? Send it to myself. So of course that returns the TX hash, and then we can just go and double check that the transaction actually went through. I'll do that because it takes a little bit of time. If you're interested in learning the ins and outs of how a native asset gets minted on Cardano, I can do a dedicated video about that, but that's really outside of the scope of this video. Let's now mint these NFTs, and we have the TX hash. Now we can go double check and make sure that our wallet now has all these tokens inside its control. You can use a UI wallet like Lace to visually view the state of the NFTs and tokens. I have Cardano pre-prod up, and I can go check the transactions. And once these transactions are confirmed by enough nodes, they'll be visible from all sources, just like our Lace wallet. Now we can see all three of my NFTs are minted, and they are there. We see the policy ID, the asset ID, they're named, they have the image URL. All is great. I'm happy with these NFTs that we minted, and yeah, that's awesome. Now let's check out our spend validator and how we're going to turn this into a smart contract. One pro tip, once you have the Icon CLI installed, what I love to do is run icon check -- watch, and this kind of becomes like a little linter slash LSP kind of in your terminal, and then you can see if you've made any mistakes when you change the file. So I have a validator here in the placeholder.icon. And it takes two parameters, the NFT policy ID and the fungible token policy ID. Now we get the inputs and the outputs of the transaction. So this is the input UTXOs and the output UTXOs. They are lists. So we have to loop over these lists. So the first thing we do is we get the input from the inputs that has the same output reference as the output reference of this transaction. This is a surefire way to get the address of the smart contract. If you're ever lost and don't know about the Icon standard library, because there's no LSP available to my knowledge, so what you have to do is you have to go to the standard library documentation and read about the types and stuff like that. Luckily, Icon is a very simple language. By design, it's very, very simple. And Cardano smart contracts in general are very simple. There's not a lot going on with them. And that's because you really shouldn't be writing a lot of complexity on chain. This is the UTXO that we're spending. So this and also allows us to get the address of the contract. Then we do this when is clause here. So this when is when the input.output.value contains an NFT, then we know the input ref contains the NFT. So we need to make sure that the output ref doesn't have the NFT and it contains exactly 10 of the fungible tokens, right? So this is the swap logic. So now we have another check here that we expect the output to contain, as you can see here, the output to contain a UTXO spending to the validator address that has 10 of the fungible token. So this is the two checks here. So we get the output, then we expect a pair of the fungible tokens does exist, and then the fungible token amount equals 10 exactly. So here's the other check. If the NFT doesn't exist on the current UTXO, then we know we're supposed to contain fungible tokens. So now we make sure that the output ref doesn't have the fungible tokens and it contains exactly one of the NFT. So we do the exact same check here, except with the NFT instead of the fungible tokens, right? So now expect NFT amount equals 1. It doesn't matter which flavor of the NFT it is. It doesn't matter what the asset fingerprint is. What we really are looking for is the policy ID, because all these NFTs are the same in our eyes. That's that. Run icon build, and we're going to get a plutus.json output, and this will contain the compiled code. Now we can consume this compiled code in our contract deployment to set up all the UTXOs we need to. All right, so we do the same type of thing. We set up Lucid with a block frost provider. We get the policy ID of the fungible token and the policy ID of the non-fungible token. We need to make sure that in our .env file, it does contain the up-to-date fungible token and non-fungible token policy IDs. This is very important. Also in the .env file, you know, as we discussed earlier, you need to have the seed phrase of your wallet. So this is like the private key of your wallet. And also you need to contain your block frost API key. All right, so in this instance, we are going to be grabbing a UTXO from the smart contract that contains the fungible tokens. So any UTXO that contains 10 exactly, which should be all 3 of them right now. There should be 3 UTXOs that contain 10. We want to swap that UTXO. Those are the UTXOs that we can spend by swapping the contract. Those are the UTXOs we can spend by swapping with the fungible token. So let's run the deploy contract logic. Let's run it one time. All right, now let's run our first deployment script. So we're going to need to do 3 of these, and each of these deployments is going to add 10 fungible tokens to one of the UTXOs of the smart contract. We're going to need to have 3 separate UTXOs because, of course, that's how our contract logic works. We need to divide them by UTXOs. So unless you have a transaction building library that can specifically define the creation of new UTXOs, I chose to simply just write it so I ran the transaction 3 times, right? But you could hypothetically build out 3 UTXOs and then define that in a single transaction. That's probably the optimal way to do it. I just didn't feel like investigating how to do that with Lucid. I'm going to skip forward into the future. I'm going to skip forward in the future because we have to wait for all 3 of these transactions to go through and be verified on chain before we go forward. Okay, now we are all set up. So now you can see in my wallet, I have 3 of the NFTs, I have 0 of the fungible tokens, and then if you check the token balance of the smart contract on Cardano scan, preprod.cardano scan, you're gonna see there's 3 transactions and the total token balance is 30 NFTs. And we could double check the UTXOs specifically by using block frost and take a look at each one of the UTXOs, and we will find that 10 fungible tokens are at the tip of each UTXO. So now we have everything set up for our logic to work. It's now time to take a look at our final logic here, which is the main.ts file. And this is the actual swapping logic. So everything else is pretty much the same. We grab the policy IDs, we get set up our Lucid with the block frost provider, and we grab our seed phrase. Now we have the actual contract address. We get the swap script, token swap address. We set that up. Now we do a call for the UTXOs at a certain contract address. So this is a call to Block Frost. They check the blockchain, they return us the UTXOs. So we're going to log out the UTXO, a UTXO. Right now there's 3 of them, but the first one available to us that has 3. The first UTXO available to us that has exactly 10 fungible tokens at it is the one we are looking for. So let's grab that UTXO. And then what we're going to do is we're going to collect from that UTXO. So this is a special Lucid function. This collects from an address. We attach the script. We add 0 datum. We add 0 redeemer. Then we simply pay to the contract. We use that call pay to contract to send the fungible token to send the non-fungible token back to the contract address. So in the same transaction, we are sending a non-fungible token back to the contract address as we claim the fungible token. So let's run that, see what happens. This is going to be the trade task. So Dino task trade. Okay. Oh, we're getting an error. Let's see what I did wrong here. So I think looks like the datum hash is wrong. Could not read undefined. So it looks like we are grabbing the wrong policy ID. So let's change that exactly because we're not getting the UTXO. So let's see, the UTXO is undefined. So let's fix that. Oh, we found the issue. We misspelled from text. It's fungible, which is a good example that of course, the from text needs to be equivalent. All right, so now let's run this logic, and we do in fact grab that UTXO. We find the UTXO, look at the TX hash that went in, the assets held by that UTXO, and the address that is possessed by. Wow, what a great situation. We now have the UTXO, and then we completed the transaction. But you're saying, did our script work? Yes, our script did work because we played by the rules of the script. Let's try to see what happens if we just try to simply claim one of the UTXOs without paying back to the contract. We got an error. Failed script execution. The validator crashed. This is exactly what we wanted to happen. The validator, when running, crashed. We failed the check of the validator. Therefore, the transaction could not be completed. What a great situation. We have secured our contract from people being able to steal these fungible tokens without returning the equivalent amount. What happens if we were to try to reclaim our NFT by passing in those 10 fungible tokens again? This is entirely possible. This is something we programmed in. Let's test the other side of it. And now let's try to grab. And as we can see, the token balance is now 2. So we have the T NFT, and then we also have 20 of the fungible tokens. So let's try to see if we can grab that NFT back. And again, we're going to run into an error here because we did not pass in the fungible token. So the script validator failed. This is great news because now we know that we've secured both ends of the transaction. So unless you do pass in that, you will not be able to retrieve that. Unless you pass in the fungible tokens or the NFT, depending on what side of the swap you're going to, you will not be able to retrieve it. Let's commit this to our Git repository so you guys can read the changes I just made. And I will see you guys in the next video. If you like this video, please leave a like. It really means a lot. Also, let me know. You got to comment. You got to let me know if you're interested in videos like this. It's super important if you are, because I won't make them unless people respond positively. Okay, bye.